Hello, welcome to the second part of the lecture for tonight. This is Chapter 11, Control Valves. So the control valve is the area that is the final control element, usually the most common one seen, that directly manipulates the process variable. I want you to make sure you know and be able to define all of these terms here. There's two parts to the actual valve. You have the actuator part, which sits above the bonnet and contains all of this information here, and then you have a valve body, which is below, which includes just the bonnet, seat, plug, and body, so on. This is the part that actually sits in the process stream. The various actuators and positioners will be covered in here as well. We'll look at some I/O signals, fail-safe positions, and special valves will be covered. We'll also be looking at some regulators as well. An instrument air that drives this valve must be dry and clean. It's critical for the valve to work and function properly. We've talked about different control valves and their fail-safe conditions. When you have an air to close, it fails open. When you have an air to open, it's a fail closed. And then you have a fail last in place as is, which we haven't really talked much about, but that's another option that's available. There's also actuator action and valve action, and you can look at this in the book and just see. It just gives you different ways that the valves and the actuators act. So actuator action here, direct and direct. So air to close and a fail open, and that's just the air that goes to the actuator. It drives it exactly as the valve is acting. And you can look at these other options as well in your text. There's different types of pneumatically operated actuators. You have a spring and a diaphragm. You can have a piston type, a couple different types. And then the operation I just talked about previously on the last screen. Then we have valve positioners. A valve positioner is used to position the valve. It can be used to give reverse valve action, and it can mimic a valve trim type. And they can also be used to provide split range control. There are different types of control valves. That's what we're going to be covering next in the text. Globes, three-way, butterfly, and ball or segmented balls. And these each are just different types of the valves, and they're just kind of talked about in your text. Again, I'm not going to spend a lot of time in this particular PowerPoint, so you can just kind of read through this and look at all the different parts to it. But there's single port globe valves, where it just has a single valve plug and a seat ring. There's a double port. Okay, this has two plugs and a seat ring. And then there's also a three-way globe valve. This is part of the three-way valves that are used. It consists of three pipe connections for mixing, blending, and flow. Okay, so you can look at that. There can also be a cage globe valve. This is a modified single port globe valve with a removable cylindrical cage holding a seat ring in place. Just different types of valves. There's also the split body valve. This consists of a two-piece body with the lower half of the body as the inlet, and the upper half is the outlet. And you can look at this again in your text and also just look over this at your own pace. We have a diaphragm valve. This is a throttling control valve consisting of a one-piece body incorporating internal weir and flexible diaphragms. So in here again, it just has the diaphragm is just pressing down whether or not it closes or opens this section here. And you can look at that again in your text and then just isolate what it goes slower here. And a butterfly valve. Now these are used in different services. You can use it in gas and you can use it in the liquid. But again, it's just this disc, and this round disc is then manipulated, and it is perpendicular. So the flow goes this way through. You can have a ball valve, a throttling valve consisting of a straight through valve, and then you can see it encloses a bowl with the hole through the center. Unfortunately, we can't look at all of these in our lab, but next time we're together, if we get together again sooner, we can look at all these different valves in our lab in F132. And then there's a modification of the ball valve because of the V-ball valve, and it has a notch in there, right in here. And a sliding stem control valve. This is a throttling valve that has a stem or shaft attached to a plug and disc at one end, and then the actuator at the other. An eccentric cam valve. It's a throttling control valve with a rotating shaft and is attached convex discs at the right angle to the shaft that closes against the seat ring for a tight shutoff and extended seat life. So this is just another type of valve. There's tons of valves out there, but these are good for control. So in here you won't be able to get to this, but I have them also listed. They're in the regular PowerPoint, and they're also listed as other videos to look at. Please look at these videos. This talks about the throttling control valve, and it gives you a chance to look at them. So here again, just modulating a fluid flow at any position between fully open and fully closed. You'll hear about throttling because that's how you control. You want to go from the range from 0 to 100%, and you use the throttling control valve to do that. Now, I want to talk about some of the issues that can happen with the valves. You can have flashing, and this is a good video talking about that. It's just when a portion of a liquid, if you have a liquid stream, it converts to a vapor. Very similar to what happens with pumps. You can have the flashing in the pump, and then they all result in cavitation, okay? And a valve, you have, it just really is amazing how it just will just damage the valve and the materials of construction. It's actually pretty crazy. So please look at this video to see what exactly happens with that. Okay. And then we want to talk a little bit about regulators, right? So we know we have instrument air regulators. There are different types of air regulators. You can have a regulator that can be used for pressure, for flow, for level, and temperature as well. And they're just in the different lines, and they regulate at different, whatever settings you want to put them at. But we generally will be looking at instrument air regulators because we use them all the time. When in your industry, you're going to be using them all the time. So generally, you're just looking at a spring-loaded pressure regulator, and we've talked about this in PC 101. You take generally stream coming off of the main instrument air line, could be up to 100 psi, and you want to run your valves between 3 to 15. So you may go through one regulator, and it just takes it to 30 as the max. And so then after that, you operate your valves from 3 to 15. So this is what you're just going to be looking at. So it just looks at the inlet, the outlet. This is just looking at the inlet, the outlet, the diaphragm, and the different valve assemblies. Okay. That's one of them. There's a back pressure regulator. Okay, maintains your pressure upstream from the regulator. So they're just different placements of the regulators where you need them to be. And a damper is an adjustable or a blade, a set of blades controlling the flow of air. We've talked about these in the louvers, right? They were in the last PowerPoint we talked about them. There's a diaphragm and spring actuator. Okay, so here's another situation. Again, just looking at them, seeing the difference between them. A direct acting actuator it extends the shaft when the air is applied to the diaphragm. A reverse acting is the one that retracts the shaft. So these just give you the direct and the reverse, again showing you another picture of that. Okay. Now we're going to talk about different other types of drives in our system. You can have a variable speed drive. Remember, we've talked about this also in the last PowerPoint about another way to control the process besides using valves. Okay, so it just works with motors, and you can have them flow by a variable speed pump as well. And then this is that pump right here, variable speed pump. Okay. So that's it. If I went too fast, let me know, and I can also talk about this some more for you guys. And here again, you'll have a homework to do, just like the other, like last class, there'll be 2 together do, and then there's 1 extra on understanding how controllers, I want to know direct acting and reverse acting on the controllers themselves. So there's a couple handouts on that. Well, have a great rest of the night. Please get all your work done and submit your work as required. All right, I'll talk to you soon.